Alright, now we're doing 7Q Street Bowling. This is by Yeet Boy 1 and 84% of people like it. We're going to imagine that we're trying to roll a ball a certain distance down a road. The ball will have a starting speed that slowly degrades due to friction and cracks in the road. Every time the ball rolls a distance equal to its speed or rolls over a crack, its speed decreases by 1. Given a speed of s which the ball starts rolling, and a road map R of the street represented by this string, we're going to return whether or not the ball will be able to make it past the end of the road, either true or false. Here's some notes. A ball with 0 speed is motionless. If a ball happens to roll over a crack, the speed decrease must only take effect after the ball has rolled a distance equal to its speed. For example, if the speed was 10, but the ball hit 2 cracks before rolling 10 distance, the ball speed should stay 10 until it reaches 10 distance, in which the speed should decrease to 7. -2, it's going to be -2 from the cracks and -1 due to friction. On the road map, this means flat ground and the X means a crack. The length of the road map will be equal to the distance to the ball's final destination. A ball must fall off the edge of the road for the code to be considered valid. Alright, here's an example. A speed of 100 and a road map of this should return true because it'll just fall off. This is just 1 and it'll fall off no matter what. And then a speed of 1 and a road map of this should return false because it'll go 1 and then stop here, basically. Alright. So first things first, let's declare a variable. We're going to declare how many cracks are in the road right here. And to do that, we're going to just say let cracks equal, and then we're going to have like r dot slice. And if you don't remember what slice is, the slice method returns a shallow copy of a portion of an array into a new array object selected from start to end, where end is not included, where start and end represent the index of items in that array. All right. So basically, like right here, it's slicing from 2, so 0, 1, 2. It's going to take camel, duck, and elephant right there. We're going to do something like this, where it slices from 1 to 5. Excuse me, let's do 2 to 4. From 2 to 4, where it'll start at 0, 1, 2, and go to 4, 3, 4, but not include 4 because end is not included. All right. So what we're going to do here is we're going to say r.slice from 0 to s. All right. So it just gets the first chunk as determined by the speed. Right. So now with that, we're going to split all of this off into its own elements. So we're going to put it in an array like this. We're going to put the brackets right there, and we're going to use this spread syntax, which allows an iterable such as an array or string to be expanded in places where 0 or more arguments or elements are expected. Right. And so we're just going to say right here, ... and now that puts all these, this string into its own, the sliced off string into its own, with each character in its own element. Yeah. And so now we're going to use the filter method, which creates a shallow copy of a portion of an array filtered down to just the elements from the given array that pass the test implemented by the provided function. So what we're going to do here, here's the syntax down here, is like we're going to filter element here, and then an arrow, and then an expression right here. So we're going to say dot filter. We're going to have element here, and the arrow. And as far as the expression, we're going to say element equals x. All right. So now we've got an array, basically. Actually, we could just never mind. So we've got an array now of this, of just a bunch of x's in a row, and we're going to say dot length. So now when we need to, we can just subtract cracks from the speed, and along with the 1 for the wherever it is for the friction. All right, there we go. That's not where it is, but it's somewhere in here. That's a lot of reading, but yeah, 1 due to friction. There we go. Anyway, so now that we've got this, now we can do some obvious stuff. We can say if s is less than or equal to 0, we're going to return false. All right. And now we can also say if s is greater than or equal to r dot length, we can say true automatically, because it'll just fall right off the edge if this is longer than this. All right. Now we're going to do the case where we need to break off one at a time and check to see if it'll, basically the main guts of this thing. So we're going to do right here an else if. And we're going to say if, it's not an else if. Else, we're going to say return. And now we're going to use recursion, which is the act of a function calling itself to solve problems that contain smaller subproblems, basically. So we're just going to say right here, we're going to call ball test again, and we're going to change the parameters to s minus 1 for the friction minus cracks. So now it's the new speed, and then we're also going to test r dot slice from s. Okay, so this takes the next chunk, and then if it goes through again, it'll take the next chunk after that, subtracting whatever. All right, and hopefully this works. Let's test it out. No, what's the problem? All right, return true, don't forget that. All right, test it out. There we go, awesome. Attempt it. All right, submit it. Very much like this one. Let's go to My Solutions. Just me on this one. Best practice in my opinion. Let's go look at the best practice. Well, I guess mine is right now because nobody else has voted theirs up. Shameless me, but whatever, I don't care. You got to do what you got to do when you're making a YouTube. All right, and we'll see you next time.